All right, you guys. So module 10, conditional probability. So this is our second or third kind of video on probability. This should look really familiar because in some of the high school classes we've looked at these types of tables we're going to be looking at a lot. So it's going to be more like breaking it down into notation and really understanding what is happening here for conditional probability. There will be a lot of this stuff on exam 2 and on the test. So and this probably for those of you that still need to take the SAT, those of you that are going to do it in October, these are going to be really important because a lot of the questions on the SAT test are using these types of tables. So I'm visiting my sisters right now. So my dog is kind of crying. You may hear him at the door where a cat is locked in. And then also she has a lot of fish tanks. So you can hear some, probably that in the background sounds like a fountain, just to give you an idea, just to set the stage here for our notes today. Okay, so let's kind of read what it says here. First, recall in module 9, we talked about independent events, okay, which are events that do not affect the outcome of each other, like flipping a coin. And then two events are considered to be dependent on each other if one event can change the probability of the other event based on whether the first event has happened or not. Thus the word conditional. Okay, so the way we read kind of this notation below is the probability of B given A is equal to the probability of A and B divided by the probability of A. Very important to remember this as we move forward. Okay, so this first table, and I think it'll make a lot of sense looking at actual numbers. Just intuitively, this will make sense, I think. So here we have a table. We interviewed 500 people on campus, so that's the total number of people. I'm going to keep to the highlighter. That's the total number of people we interviewed was 500. Okay. About whether they are a student or not. We also took note of their gender. Okay, so here we have student, here we have gender. Okay, so we have a total amount of male students here. So these are all our male students, or I'm sorry, all of the males. Some are students, some are not. Here's the total number of males. And then we look at our females. Okay, 224 are students, 30 are not students for a total of 254 students. When you add 246 plus 254, you get 500. And then down here, we also have totals. We have the total number of students was 436. Well, that makes sense because they interviewed these people on campus. So it makes sense that the majority of the people were students. Probably the other people were faculty or staff or family maybe of the students. So 64 were not students. This makes sense. So the first thing it wants us to do, so we're not going to talk about conditionals yet. We're just going to straight up talk about probabilities. Remember, the probability is a regular probability is the probability of something happening divided by the amount of times that the total amount of sample space, right, times it happens. Find the probability that a randomly chosen person will be male. Well, we're just going to look at the total number of male, which is 246, divided by the total number of people interviewed is 500. So this is going to be, I'm going to make that approximately using the calculator, 246 divided by 500 should be less than 50%. 49.2. I guess I don't need to use the approximately. I'll just leave it as 49.2. So 49.2%. Cool. Question B, find the probability that a randomly chosen person will be a student given that that person is male. So we already know that the person is male. So our total, our denominator, is going to be the total, 246, the total number of males that were interviewed, okay? Because we already know that they're male. It's written backwards, it's written given that they're male. We already know they're male, that's gonna be our denominator. Then the numerator is gonna be the probability that it is a student and also male, and that's going to be 200, okay? So that's gonna be this box, I'm circling it. That is a male student, okay? That is a male who is also a student. And then this, we already knew that it was gonna be a male going into this. Like say we knew we were picking from the hat that only had male names, so our denominator is gonna be 246. So here, the probability is gonna be 200 divided by 246, whoops. Look, I always have trouble with those double digits. 0, 2, 4, 6. Approximately 81.3. Okay, and that makes sense. And this time I am gonna use approximately 81.3% because the majority are going to be male, right? I mean, students. We know that it's male, the majority are going to be students, okay? So C, find the probability that a randomly chosen person will be a student given that that person is female. So we're gonna do the same things, but now, okay, our denominator is gonna be 254 because we already know that it's female and that's how many females that we interviewed. Okay, and then the numerator is gonna be that it is a student and a female, which is going to be 224. I'll circle that square up there, 224 over 254, because we know it's gonna be a female. Now I'm gonna, because I did that wrong. All right, didn't do it wrong, I'm sorry. Circled the numbers and then you couldn't see what it was. But now, so now we have 224 out of 254. So 224 divided by 254. So that's 88.2% approximately. Okay. Arnie, hush. All right, what does D want us to do? D wants us, oh, there is no D. We're just gonna keep going. Okay, an easier way to read the table for conditional probability is looking at question B again. Find the probability that a random chosen student will be a student given that that person is male. Okay, this is what we just did. So, right, we know that the probability that it is a student given that it is a male. This is just what we just did. Okay, it was 200 over 246. Okay. How is this different? Why did they say that this was different? What's a good question? Find the probability around is given that that person is male. The phrase after the word given narrows our potential group, in this case, male. So we only have to look at the row. Oh, so it just straight up took that row out of the table. But as you can see, you just get the same, answer here. It just took that out. Which is just going to be this. I can't remember what it is from the top, but it's going to be the same. Okay. D, find the probability that a randomly chosen person will be male given that they are a student. So we've kind of flipped the book. Given that they're a student, so we actually need to look at the total number of students from the table, which is 436, right? The total number of students, it's that yellow, 436. That's going to be our denominator, okay? And we want to know if we have a hat full of students, and we choose a number, what's the probability it's going to be male? It's going to be 200 out of 436. So it's kind of doing the same thing. We're just looking at that column now instead of the row. right? We know it's a student, so it's gotta be in that column that yes, it's a student. So that's gonna be 200 out of 436. Okay, which is going to be approximately 45.9%. And next, find the probability that a random chosen person will be female, given that that person is not a student. So we're going to go back up. Okay, so it's given that they're not a student. So this time we're only working out of these 64 people. And out of those 64 people, 30 were females. Okay, so less than 50%. (46.9%). Okay. And it just says be careful you don't mix them up with the non-conditional questions like A. Okay, we already did that one. And G, find the probability that a randomly chosen, so this one, oh, is F the same as A? Let's just do it to be safe. Find the probability that a randomly chosen person will be a male student. So a male student, there were 200 male students. So that would be 200 out of the total number, which is 500. So 200 out of 500. So that is the same as 2/5, which is the same as 40%. And G, find the probability that a randomly chosen person will be a male, but not a student. And so male, not students, were 46. So just 46 out of 500. It's not given any conditions. It's just the 46 out of the sample space, the total sample space. And I can't do that in my head. So 46 divided by, whoops, that wasn't what I wanted. 46 divided by 500. That's going to be 9.2%. Okay. Okay, and then I think I went over this in the last video with kind of a set of cards. So this is going to be the same thing. Sampling with replacement. Okay, and then we'll talk about sampling without replacement. So sampling with replacement, the randomly selected unit is returned to the population after it's selected each trial. So what that means is if you are choosing a card from a deck of cards, okay, sampling with replacement means you choose a card and then you put it back into the deck, okay? So this says, what is the chance of drawing 2 black markers in a row with replacement? So this doesn't give us a question. Am I missing something? So I'm going to save this until I can find out what question it's talking about. But no, we are coming back to visit this because this does become important. So what this question is going to look like is if you have like a box of markers and with a bunch of different colors of markers, and you want to know what the probabilities of choosing 2 black markers. But again, I need to actually find that question. So I'm going to stop this video and I will go over this part in class. Sorry about that, you guys.